We are back, Advent of Cyber. Today is day 5, and it's going to be IDOR. So let's go ahead and check this out. Santa's Little IDOR. The elves of Wareville are on high alert since McSkitty went missing. Recently, the support team has been receiving many calls from parents who can't activate vouchers on the TryHackMe website. They also mentioned that they are receiving targeted phishing emails containing information that is not public. The support team is wary and has enlisted the help of the TBFC staff. When looking into this peculiar case, they discovered a suspiciously named account named Sir Carabane, which has many vouchers assigned to it. For now, they have deleted the account and retrieved the vouchers, but something is going on. Can you help TBFC staff investigate the Try Present Me website and fix the vulnerabilities? Today's learning objectives are going to be understanding the concept of authentication and authorization, learn how to spot potential opportunities for insecure direct object references, exploit IDOR to perform horizontal privilege escalation, and learn how to turn IDOR into SDOR, secure direct object reference. We're going to go ahead and connect to our machine. All right, now we have our attack box up and running. Let's go ahead and see what we're doing for today. So the first question I did see is the acronym, and it's going to be insecure direct object references. And I believe we can answer the second question as well, just from the learning objective. Exploiting the IDR, found in view accounts parameter. So now I need to go back up and just see what's going on. Have you ever seen a link that looks like this? When you saw a link like this, have you ever wondered what would happen if you simply changed the package ID to 11 or 12? In its simplest form, this can be a potential case for IDOR. IDOR stands for Insecure Direct Object Reference and is the type of access control vulnerability. Web applications often use references to determine what data to return when you make a request. However, if the web server doesn't perform checks to ensure that you're allowed to view that data before sending it, it can lead to serious sensitive information disclosure. This is how data leaks happen. A good question to ask is, why does this happen so often? That is a good question. We need to understand references and web development a bit more to answer this. Let's take a look at what a table storing these package numbers from our link example could look like. So let's see, package ID 1001 is Alice Smith. This is her address, and the status of her package is been delivered. The other one is in transit. Carol is out for delivery. Daniel has a pending order, and Eve has a return. If the user wants to know the status of their package and makes a web request, the simplest method is to allow the user to supply their package ID. We recover that data from the database by using the simplest SQL query of select person, address, status, from packages, where package ID equals value. However, since package ID is a sequential number, it becomes pretty obvious to guess the package IDs of other customers, and since web application isn't verifying that the person making the request is the same person who owns the package, an IDOR vulnerability appears, allowing attackers to recover the details for packages belonging to other users. Even worse is when a feature like this doesn't require a user to authenticate, then there would be no way to tell who is even making the request. To dive a bit deeper, we need to understand authentication, authorization, and privilege escalation. I'm not a fan of the vulnerability name. I prefer the name authorization bypass if you want to understand my reasoning. Identity defines our reach. To understand the root cause of IDOR, it is important to understand the basic principles of authentication and authorization. Authentication is the process by which you verify who you are, for example, supplying a username and password. Authorization is the process by which the web application verifies your permissions. For example, are you allowed to visit the admin page of a web application, or are you allowed to make a payment using a specific account? You may think that authentication only happens when you supply your username and password, but that's actually not the case. After providing your credentials, you receive a cookie or a token called session information. Every subsequent request you make to the application includes this session information, which is verified by the application. This initial verification process is still authentication and happens for each request. This is why websites will often redirect you back to the login page. It means your session information has expired, and thus you need to re-authenticate your credentials to receive new session information. Authorization cannot happen before authentication. If the application doesn't know who you are, it cannot verify what permissions your user has. This is very important to remember. If your IDOR doesn't require you to authenticate, log in, or provide session information, such as in our package tracking example, we will have to fix authentication first before we can fix the authorization issue of making sure that users can only get information about packages they own. The last bit of theory to cover is privilege escalation types. Vertical privilege escalation. This refers to privilege escalation where you gain access to more features. For example, you may be a normal user on the application, but can perform actions that should be restricted for an administrator. Horizontal privilege escalation. This refers to privilege escalation where you use a feature that you are authorized to use but gain access to data you are not allowed to access. For example, you should only be able to see your account, not someone else's account. IDOR is usually a form of horizontal privilege escalation. You're allowed to make use of the track package functionality, but you should be restricted to only performing that tracking action for packages you own. Now that we understand the theory, let's look at how to exploit IDOR practically. Iterate digits, observe responses. Let's start with the simplest example. So these are credentials. This is our attack box. So we now have this loaded up here. Let's go ahead and try to log in. And now we can see all the children names, vouchers. We can add them a gift and see their birthday. Let's start by using the developer tools of our browser to better understand what is happening in the background. Right click on the page, click inspect. So let's go ahead and do that. So then inspect, and then we're gonna go to the network tab, which is gonna show all the requests in real time. So if we reload, we'll see a bunch of get requests, which is basically pulling all the information. Favicon is the logo. We have the index, which is the page. We have vouchers, and we even have view account info for user ID, which is something that we're gonna wanna look at a bit later. Let's see if I can zoom this out a little bit. Over here, it says, let's take a closer look at the view account info request. Click on it and you'll see the following. So that's what we're looking at here. We can see that parameter of user ID 10 is me, or Niels. In the above image, we can see that user ID with the value of 10 is used for the request. If we click and expand the response tab, we can see that user ID corresponds to our user, which is, again, Niels. This tells us that our application is using user ID as a reference for getting details. Let's see what happens when we change this. In the developer tools, navigate to the storage tab and expand the local storage dropdown. And here's that information again. And here's our authorization token, which is the cookie we talked about earlier. Let's change the user ID to 11 and see what happens. Let's refresh the page. And now we can see additional things that we couldn't see. We're still logged in as Niels, but instead of seeing our children, we're seeing information for what looks like maybe the admin. We can see available vouchers. We have 6 free gifts to give away. So that is an IDOR vulnerability. So let's see what's here now. Let's just double check. So for that, I believe we'll need to go back here and look at few accounts. So let's go back to storage and play with this a little bit until we can find out which parent has 10 kids. So we already did 10, we already did 11, so let's do 12. Let's refresh. This person has 0 children. And it looks like we found it now. This usually looks like they definitely have 10 kids or maybe more. Let's go back and see which user ID was 15, and that was correct. And it looks like that was the last flag here. There's a couple bonus tasks. If you're the type of people that do the Easter eggs and bonus tasks, please drop a comment and let me know what I'm missing out on, because I currently do not have time. So I'm trying to speed run this and then upload it. Yeah, so I'm just gonna skip all this. If you did this part of it and you did the Easter egg of it, drop a comment and let me know what I missed out on. But for now, we're pretty much done with this. And we are done. If you're watching this on YouTube, make sure you follow me on Twitter at rxsklife. If you're watching this on Twitter, make sure you follow me on YouTube at rxsklife. Thanks for watching, and I'll see you again tomorrow.